Good evening, everyone, and thank you for listening to the Futurati podcast, where we dive into how emerging technologies will impact the world and your bank account. I'm Trent Fowler, and joining me, as always, is my co-host, Thomas Fry. Thomas and I are futurists, keynote speakers, and consultants with decades of experience in analyzing trends and communicating new developments to audiences across the world. Reach out to us at futuratipodcast.com/contact-futurati if you'd like to hire us for consulting, to speak at your event, or to advertise on our podcast. Thomas, we just finished up a wonderful interview with Dr. Julian Togelius, whose research lies predominantly in the intersection between gaming and artificial intelligence. But we also spent some time talking about AGI at the end. I thought the game section of the conversation was unexpectedly rich, and it occupied more of our time than I thought it would. What are your reactions?
Oh, I agree. He has, I don't know, he kind of plays down his intelligence.
His academic credentials, yeah.
Yeah, he's very bright. The part that really caught my attention is when he said that, when I asked him about the singularity in 2029, and he says, well, we've never had any time in history where everything's changed all at once. And that's kind of an interesting baseline to look at. And so I think that's correct. So I don't think we're going to see everything change all at once like so many people are predicting.
Yeah, he had a lot of interesting little perspectives on issues that were really refreshing and very productive. So you described games as being like a mold of our cognitive abilities. It's made in our image in a really important way, but it's not a direct mirror exactly. It's more like some scaffolding you can explore, but built to your proportions and exactly the way your mind would want to work, which led us off on like a 25-minute conversation about, the sorts of things you could train with games and the impacts they have on human cognition. And that, of course, segued into the discussion about AGI. And I was kind of surprised that he was as bearish on the concept as he is, because it doesn't really come through in the book. Like, he just wrote a book about AGI, but he's like, at first he says, well, I think the concept just doesn't have any content. And then he kind of came around by the end. So that part was sort of surprising to me.
Yeah, I liked it when he said that he's probably ending up a disappointment to his 20-year-old self.
Yeah. Well, hopefully, he wasn't a disappointment to us, and hopefully he's not a disappointment to you either. I thought it was a wonderful interview, and I'm sure you will as well. So without further ado, this is our conversation with Julian Togelius. Tonight, we're joined by Julian Togelius. Julian is an associate professor of computer science at New York University. His research lies at the intersection between computational intelligence and games, and he is currently focused on using evolutionary algorithms to generate levels, maps, or game rules. In addition, he has worked on a wide variety of problems related to evolutionary reinforcement learning, and he is the author of a forthcoming book on artificial general intelligence through MIT Press. If you enjoy this interview, please subscribe to the podcast and share it with your friends, and don't forget to check our website, futuratipodcast.com. Julian, thanks so much for coming on the show.
Thank you, Trent. Great to be here.
Let's hear a little bit about your background, your interests, and what brought you to working on the projects you're working on today.
Yeah, so my background is that my background is long and varied, but basically I almost failed math, so I studied philosophy to understand the mind. And then somewhere along the way, I discovered that, I need to understand the mind, I need to build minds, and philosophy isn't really getting me that far. So I kind of gradually became a computer scientist, and then so I could do artificial intelligence. And along that way, I discovered that the best place to do artificial intelligence, or the most interesting one, is in games. So I do a lot of work on AI in and for games. And when I say games, I don't mean like abstract mathematical frameworks. I mean video games, StarCraft, Super Mario Bros., Minecraft, things like this. But I do it with an eye towards general intelligence. So I spent a lot of time thinking about general intelligence, artificial general intelligence, what it is and what it is not, and how we could possibly go there. And I spent a lot of time building benchmarks and frameworks. So where I am in terms of where I work and so on is that I'm currently an associate professor at New York University in one of our multiple computer science departments. And we're all friends, but, you know, institutional politics make it so that we're spread out in different places in this vast New York University. And I'm also a co-founder of an AI startup called Model.ai, where we do AI surprise, AI for games.
Interesting.
Since you brought up AI gaming, can you give us kind of a hint as to how AI gaming is going to change gaming culture over the next decade?
Oh man, yes, that question's up in the air, like, right? I think, or what I want to happen, and I think will happen to some extent, is that, you know, people speak a lot about democratizing game development, and democratizing can mean different things, but I think it will be a lot easier to create some kinds of games. We are definitely going to get to the point where you can say a few words and, you know, get a game and then talk your way through improving the game. Are you going to get something that is of the same quality as like the latest Assassin's Creed, or like, you know, as novel as something that Jonathan Blow would come up with? No. But it's going to make games a viable space of expression in a way for like ordinary people, in a way that it hasn't been before. Normal people are going to be basically like, yeah, I want to say this thing and I want to say this with a game, sort of a playable experience of some kind. In the same way as you can, like, you now make an image or write a text or something like this. Mm-hmm. Another thing that I think will happen, there's the much maligned term metaverse. And I think the term metaverse is very silly. But I do think that something like persistent online worlds will happen. I mean, they already exist and have for a long time, but they will be more common and more things will happen inside them. And AI has a huge role to play in there, to basically creating the content that isn't there, providing collaborators, adapting the games to you, and like making very disparate pieces of game worlds sort of fit together in different ways. These are two of the main things.
It sounds kind of like, in order to have a rich world of any kind, there's a critical mass of minds that you need to have to structure it and for there to be things to do. And, you know, a digital world will almost certainly, I mean, until the advent of AGI, will certainly be less populated than the actual world, because there will always be only a small fraction of people doing it. And so some of the stitching that goes into making a world will come from these generative algorithms.
Yeah, I mean, it's already the case that, like, you know, most games are big enough that they need more content than humans are ready to provide. You know, with games having development budgets in, like, you know, hundreds of millions of dollars for the big ones, you'd think that, oh, it's because they put like literally 1,000 people working on it, but still, like, you know, there isn't enough people to do everything. So, I mean, for a long time now, we've had procedural algorithms to generate things like foliage and other kinds of vegetation, various aspects of the natural environment, like rocks and stuff and buildings and so on. But we are more and more getting to the point, and of course NPCs that roam around there, basically. We're getting to the point that these technologies are getting much better, and we're going to see games with a lot more of, you know, everything. Then comes the question, and this is like the really interesting question in terms of what we actually value as humans. Will it be good enough, and will it be meaningful enough? To what extent do we want to sort of exist in a world of all these algorithmically generated things and creatures and people? Will it feel meaningful to interact with them? I mean, I don't know if you played No Man's Sky at any point.
No, but I heard about it.
Yeah, No Man's Sky is, and if you played No Man's Sky now, it's a very different game to how it was back in 2016 because there's literally been like 20 major updates or something. It's a game which presents you with this extremely rich world, which is extremely diverse, and basically everything is like algorithmically generated, which is very, very cool. Yeah, it's very, very cool. But you also get this feeling of like, I land on this planet that no human has ever seen before because there's, quintillions of them or something like this. And I meet the whole ecosystem of species of animals and plants and so on that no one has seen before. And you sort of interact with it, but you get this feeling like, why am I doing this? Why am I pushing this bits and bytes around? Does it matter if there isn't a human there on the other end? And I think the answer to that will vary very much depending on who you ask. For some people, that's great. For other people, you will very much you will want to interact with something that a human has built exactly because a human has built it. I'm sort of, in between, or I'm like on Monday, I think one thing, on Tuesday, I think another. But I think this would be like a core, some kind of like axis of alignment in culture and so on. How much do you want to interact with all these kind of generated content in these generated worlds? And also, how can you build these virtual worlds and games so that they kind of foreground and what's the authentic human experience, while still giving you the freedom to do whatever you want and explore whatever you want in this giant big world. I'm not sure this is what we were supposed to talk about, but it's one of these things that keep me up at night.
I think it's an unexpectedly deep question, and one that will only grow in importance in the decades ahead. Because on the one hand, in certain contexts, it's obvious that the answer to the question whether or not people will find interacting with digital minds meaningful is yes, right? So you see the phenomenon of like the replicants, for example. I don't know if you were following this, but there's like a company that offers, I guess they're like AI companions or AI girlfriends or something kind of like this. But people became very attached to them, and then there was an upgrade, and the personalities changed, and people were heartbroken. They were like,
"Oh wow!"
People said, "I wish I'd had the chance to say goodbye." About a piece of software. So like obviously sometimes the answer is yes, but as you were describing, what was it, No Man's Sky, is that what it is, the for open immersive world, there's a kind of sterility to being a perpetual first, right? Like the first time you see something no one's ever seen before, maybe that's really cool, but if you just keep hopping one to the next and there's no one coming behind you, it's some kind of meaning is sapped of it. It's like like all of these digital worlds are ways of forming connections by proxy where we can't be geographically close for whatever reason, but it still matters that it's people. And I think I don't really have a good answer as to whether or not most folks will come down one way or another, but I do think it's really important because there's going to be a lot more of this stuff, a lot more.
Yeah, definitely. And I mean, we derive meaning from interacting with other people in some way, even though it's super indirect, parents and kids interacting via building things for each other in Animal Crossing on the Switch, for example, which is an indirect way of doing it, but it's still like, it feels good. You're like, oh, you're outfitting this little apartment for your son or something like this. And there's a huge, not only tech problem, but a huge design problem in how do you design worlds to give you the freedom you want, because people want this. People want like the freedom to do whatever they want in these worlds. And like for as long as there have been video games, there have been many players, maybe most players, like complaining that the limits of the game are stupid. What happens? Why can I not pick up the goat? Why can I not go past this wall? Why can I not do these and these things? Why is the game limiting me so much? And there is one aspect of this design is like letting you do, how can we let you do everything? And that's one of the impetuses for the metaverse, as I see it. Like that's part of why people want it. But at the same time, yeah, human connection.
So one of the things you're talking about is how much cheaper it's getting to build games. So stretching this out over the coming decade, how long before we have the first one-person company that designs a game that becomes a unicorn game and reaches the top of the charts?
I mean, I would like to say that this already happened, but I don't have any direct example right now.
There are big ones. There are like I have a friend who does game design, and he says that there are some where it's like a one-man show where he makes $1 million a year or something.
Yeah, so basically, and also like the game industry is notoriously not forthcoming about like revenue numbers and stuff like this. But basically, or like I would like to add, not forthcoming about anything. It's not the secretive stuff. But in the beginning of video games, like where computers were limited and there just wasn't much storage space and everything was new and fresh, a lot of hit games were made of like one or two people. Now, these people have to be like the designers, the testers, the programmers, the artists, the everything, but also But even these days, you find these odd games like Vampire Survivors came out, 2 years ago? I don't know how much it made, but it's become pretty big and spawned its own kind of subgenre of games that are like it. And this was made by this one guy who, was like an unemployed Italian game designer in London who was playing around and had his idea once, and then it just worked. And also all the classic games that spawned like giant franchises. Sure, Angry Birds was made by a company, and I don't know how many there were at the time, Rovio, but it wasn't a huge project to begin with. It became huge later on.
Hello, this is Trent Fowler, co-host of the Futurati podcast. One of the most common pieces of marketing advice I've come across is to know your audience and give them what they want. One difficulty in podcasting is that it's actually pretty hard to do this. None of the major platforms give us any way to reach out to you, our listeners, to find out what you enjoy about the Futurati podcast and what you'd like to see done differently. So we've decided to record this commercial and ask you directly to reach out to us. Head over to futuratipodcast.com, go to the contact page, and drop us a line. Tell us about your favorite and least favorite episodes, what you'd like to see us cover in the future, and anything else you want us to know. We produce this show for you, and we want your advice so we can make it even better. Thank you.
Okay. Yeah, Thomas maintains this ambition of being the oldest unicorn. He wants to. He's perpetually asking this question in the hopes of striking gold somewhere. I wish him the best of luck. We need sponsors if that happens. So sticking with the game theme, I am curious as to why you think it's a uniquely well-suited test bed for artificial intelligence and eventually artificial general intelligence as well. I think there's some obvious answers to that question, like you can reset the simulations and make them arbitrarily complex and so forth. But maybe there's something deeper to be said there.
Yes. In fact, yes. Let's start with the obvious stuff. So basically, when I started my PhD, I thought I was going to do evolutionary robotics, using evolutionary algorithms to design neural networks for robots. And then I discovered that robots are very slow, they're expensive, they break down all the time. You have to change the tires because they get hot, and the battery and the wires get tangled, and you have it, like all this kind of stuff. And nobody wants to do this. Or like some people care about this, but I don't understand. It's like people who do home redecoration for fun. Not me. I live in Manhattan, but basically above all, it's slow. So I discovered you can run the same experiment 1,000 times faster in a simulated environment. Now, real roboticists would then say that simulated environments are not real. You're just coding up something and it doesn't matter. It doesn't apply to the real world. Now, so there's basically kind of no grounding for what you're doing. Like your experiment doesn't really matter. You're maybe not solving the real problems. The beautiful thing about games is that they have their own grounding. Their grounding is that they're designed for humans to play them. And a well-designed game is real in a sense that like a crappy robot simulation isn't, because it has been designed to be played by people, and thousands, maybe millions of people have played this game, which makes it meaningful. Now, if you ask why, it is because game design is a cognitive science, which is constantly mapping out the capabilities of the human minds by providing challenges to it. So we started out like, game design as a discipline started out by random fumbling around in the dark, like basically most disciplines. And then we discovered that certain things worked. You find patterns. You find that basically, oh, you're right. If you sort of provide certain kind of animations that make the game feel weightier and more interesting, you don't want the board game, you don't want the win state to be too predictable early on. You want that to be predictable as late as possible, which you can measure in various ways. You want the multiplayer game to be balanced in various ways, and so on. You may want challenges at different time scales. You may want challenges at different macro things. You want to provide the joy of curiosity for like exploring the environment. It goes on and on and on and on. The long list of like, heuristics and design tips. And basically what happens is that once you start pushing towards like, how can you design the best game that poses particular challenges for a particular cognitive capacity. Like, how can you design the best kind of fast-paced FPS? Like, can you out-doom Doom? Can you doom it even more,
Well, Halo 2 and 3, they will never...
Oh, yeah, fantastic. I don't think. Three particular. Halo 3 is somewhere up there in the pantheon. I agree. And basically... and they discovered a bunch of whole things, like the whole 30 seconds of action loop that they built the Halo games specifically about. It's like, it's actual progress in game design. And then you start like exploring to the side. So what are other kind of challenges we haven't discovered? Now you start combining like the different kind of puzzle elements with different action elements. You start building games around being able to identify and parse emotions. You start building games around being able to pack stuff, like basically you start building games around doing the right kind of investments, and it's just like spreads. And the other really important puzzle piece of this argument is Ralph Koster's theory of fun for game design. Basically, Ralph Koster, very accomplished game designer, his theory is that games are fun or engaging or whatever you want, largely because we learn to play them as we play them. They provide challenges for us, and then we sort of get on with and playing them because we want to learn better how to play them. A good game has this kind of long, smooth learning curve, and towards the end, you're very good at it. So basically, if you accept that this is a main source of engagement for games, what you will have to accept is that game design is trying to map out ways of challenging your mind, which you find enjoyable. And in the end, like, game design provides this kind of like, what do you call it? This negative image of our cognitive capacities. So it's kind of a mold of our cognitive capacities.
That's a very interesting thesis. I think that games are a mirror image, a reflection of our cognitive capacities and a mold of them. And you made reference to games that can be built off different premises or a different set of primitives. Like if you're talking about games that center on recognizing emotion, I can think of games with emotional elements in them, but none where the focus is primarily on recognizing emotion and where like the basic primitives are all emotional. So what are some interesting directions that could be taken? Like off the top of my head, could you train synesthesia? Like what
you probably could. You probably could. I mean, if you take an example of recognizing, if you ever played to take like a huge blockbuster game, The Witcher Part 3, which is like one of the biggest games of whichever year it was, 2018, I don't know. One of the 16. One of the beautiful things there is like how you actually need to navigate the emotions of people around you, or they will abandon you, set you up for crazy traps, and or extort you in various ways, which I think is great. I fell into one or two traps like this. Like ostensibly, it's a game about like killing monsters with sword and stuff like this. But there is a part of this. There are other games like there's dating simulator games. There's all kinds of like subgenres of role-playing games and so on, where this kind of trying to read emotions has a really, really certain role, or kind of key role to it. But yeah, as to your question was what you can train with it.
Yeah, what you could train with it. I'm thinking like, would there be a way to structure a game such that you expanded executive function somehow? Like there's some limited evidence that certain kinds of tasks, like the dual in-back task, can expand working memory, which is a sort of holy grail, right? That's the RAM of your mind. That's where, like, if you can hold more elements in it and keep things more straight, then you're effectively more intelligent. Like that's a big part of what it means to be more intelligent, right? So could you train that? But it's super hard. It's a real grind to do it, and it's incredibly difficult. So it's like, well, maybe there's a way to do it with a game such that you actually are changing in a subtle way some underlying process, but doing it positively.
I think every game trains a capacity. The big question is how well it generalizes. And I mean, there's been these studies that show that like management, if you play World of Warcraft and make your way up a guild, that actually transfers to real world people management skills, for example. And I'm pretty sure that you can learn a lot about like from civilization, or like from a game where you construct, devices and so on. You can learn protein folding from playing Foldit and so on. But the big question is how well it generalizes to something more general, underlying. And this is kind of how we through the back door kind of segue into the question of general intelligence, maybe?
The segue. So carefully planned for in the opening seconds.
Okay.
Yeah, here
indeed.
we are.
No, but Nintendo had these brain training games, for example, and these were not shown to. I mean, you play them and you got better at playing the brain training game. They have not been shown to actually improve ability to do anything else. So on the other hand, they may help stave off like dementia or something like this, but I'm not sure if there's any evidence for this. But basically, the generality of what they teach is very, very simple, which is because you can basically overfit on them. If you learn to do one particular task, you will overfit on it. And this is the same for humans and for machine learning algorithms.
So do you have any numbers on your fingertips as to what percentage of the gaming world is on VR right now versus normal screen?
Minuscule.
Very small. Okay.
Yeah.
So I've gone through this exercise with some of my groups in the past, asking what the act of watching television will be like in 2040. Will we still be looking at an appliance in the front of the room? Will it be a projected image? Will it be digital wallpaper? Will it be three-dimensional? Will we have the ability to interact with it? Can we touch and feel things? Can we change the image of these things to look like our friends and our relatives? Can we buy things by touching them? There's all kinds of interesting questions that come out. So I'd love to hear some of your thoughts on that.
Are you enjoying this episode of the Futurati podcast? If so, please like it, Give the show a 5-star rating on Apple Podcast, Spotify, or wherever you get your podcasts, and share it with your friends. By far, the best way to help us grow is to spread the word on social media, which will expose our content to more people and help us continue to bring you interviews with world-leading experts in AI, quantum computing, cryptocurrencies, and so much more. Thank you in advance.
Yeah, here is where I'm going to come across as the boring skeptic, but I am entirely unconvinced by VR. I don't see the point for it. I mean, history will probably prove me wrong. In fact, I somewhat hope that history will prove me wrong. It would be kind of cool if we came up with some kind of good use for VR, but I cannot really imagine it, except for very specific applications, like, oh, here's a simulator to teach you how to do a particular job. But mostly, like, pure VR just feels like it removes the social aspect of what you're doing, and it also is very hard to do in like an outdoor setting because you're cutting yourself off. So basically, it's something you'll be doing alone in your basement or something. And it also like, you have all these issues of motion sickness. Maybe it can be overcome. I am a little bit skeptical about that as well. Or I think it depends on the person. I'm the kind of person who avoids taking buses because I get motion sick. And even in the best case, it just doesn't seem super compelling to me. AR, on the other hand, where you're actually seeing the reality and you can overlay things on top of reality. I think AR will be big, maybe ubiquitous, but I am not sure it will mainly be a games thing. It would be very cool. I mean, I've had various ideas for how to generate environments around the world you see, like basically you're viewing an indoor scene and basically, please create me a platformer game that sort of is laid out on this environment or something. Interesting research challenges. I am not certain whether it will be a big games thing. On the other hand, like some of the real killer apps for AR, one of these things I really want, and a lot of people will hate it and will absolutely try to get it banned. It will probably get banned, but it will be ubiquitous even if it gets banned, because the demand will just be so enormous, is name tags. I just want to be able to walk out on the street and see what people's name are and how I might know them through like social network connections. Maybe something else useful for them if something pops up that I should know about them, like, do they work with something interesting and so on. I'm terrible at recognizing faces. And I understand this is a privacy nightmare and I think it will get banned. But as I said, I think it will first get banned, but then everybody will use it anyway because it's just going to be so useful.
Well, we need like a technology on the other side that allows you to control what other people are able to see and what sort of information you project. Like in Hannu Rajaniemi's Quantum Thief trilogy, the Generality technology that facilitates that, and it plays an important role in the plot.
Yeah.
Like you can hide your face, or you can like be a total open book. You can annotate yourself information, and you can control it on a per person basis and set defaults and stuff. So it really changes sort of the protocols for interacting.
If people agree with the protocols, if like they will implement it, we'll see what happens. It's like,
I've often thought that we're a very two-dimensional society, that we're trained from birth to think two-dimensionally, two-dimensional paper, two-dimensional whiteboards and blackboards. Even the screens that we look at are two-dimensional, and we haven't had any good technology for projecting things holographically, three-dimensionally. And so it always seems like there's a big opportunity to move into the three-dimensional world, but VR, as you're saying, really hasn't caught people's imagination.
Yeah.
I'm guessing you're not going to be hired by Zuckerberg anytime soon.
Nah, it's okay. It's okay. Although I must say that I started liking him more and more because of what he's doing with open source AI, which I think is great for the world. But hey, you don't have to like all of it.
Yeah, he's really rehabilitated his image in some interesting ways.
Yeah,
so he's a fascinating PR case study. So since we have at long last broached the question of intelligence and cognitive faculties, a big part of the reason we invited you on in the first place is because you have a forthcoming book on artificial general intelligence. So a lot of your research is at the intersection of AI and games, but the new book is on general intelligence as such. So I want to pivot to discussing that in a little bit more detail. And I thought we could start in an obvious place, which is how you try to define this term. It's famously difficult to get at the essence of general intelligence, even though, we can clearly see it all around us. So, how do you define that? Because I think there's a lot of really interesting philosophical territory there. Depending on how you parse this concept, it really has serious implications for how you think about things like safety.
Yeah, so I think we cannot define general intelligence or artificial general intelligence. I think it's inherently impossible, and we shouldn't try, and we should stop talking about artificial general intelligence. It's a red herring.
So you don't want them to buy your book.
No, I want them to buy my book, read it,
but don't read it.
Me, and I couldn't say no, read it and agree with me. I'm like, that's it. I'm not going to talk about artificial general intelligence because it's a bad concept that's misleading us. I mean, in a sense, I'm not saying anything new. Nobody, there's this old Alfred North Whitehead said at some point, like, all of Western philosophy is footnotes to Plato and Aristotle. Basically, only Plato, right? Like, who was it? It was Borges said that everybody's, or Borges said that everyone is.
Whitehead that said
Platonist,
is footnotes to Plato.
Yeah. It's like Borges said that everybody's a Platonist or an Aristotelian, like, basically, and you choose one or the other. But I mean, all of computer science and AI are footnotes to Turing anyway. So. And Turing said this in his 1950 paper, Computing Machinery and Intelligence. The outcome of his paper was basically that the question, can a machine think, will be considered so meaningless as to not be worth discussing. So, I mean, he said this in 1950, and we still haven't come there, because it's hard for us to abandon cherished concepts, even when they are actually sort of hindering our progress. So, I mean, this being said, I got into
what's the cherished concept? Thinking,
general intelligence, and maybe even intelligence. So, I came into artificial intelligence because, well, I said at the beginning that I gave up in philosophy, and I came into it because I wanted to understand intelligence by building it, and it sounded great. Like, here is AI. This kind of discipline where we're trying to build intelligence. And yeah, it's great. I'm making career out of it, But when you look inside the box, there's basically all these different methods that are quite different from each other. And I am not one of these people that say that, we have rediscovered backpropagation, and therefore that's the end of everything. Like, in fact, when you sort of keep looking inside the box, a lot of recent AI progress is not only due to gradient descent. There's a big component of search or planning in there as well. So you have all these different methods that aren't really similar to each other. They take very different sort of starting points and make very different philosophical assumptions. What they have in common is that we have at some point thought that we can use them to make computers do something that we think of as intelligence if humans would do it, which is fine, but it's kind of helping underscore that there isn't a substance to it. And I think when we go down the route to, like, what is it we're trying to model? What is this thing called intelligence? Intelligence is something that humans can do. And then we have, like, basically some very, very unclear ideas about which of our capacities are intelligence or not. Like, lifting a heavy weight is not intelligence. Calculating the square root of 49 is intelligence. Why? This is a little bit unclear. Well, one is cognitive, the other is not. Okay, so what do you mean by that? we can't really draw a boundary there. And then you start thinking about is there something that underlies all these things we call cognitive, all these things we call intelligence? And probably not, because that's not how evolution works. Evolution made our minds, or made our brains which produce our minds, by like trying to become more fit, like one step at a time, trying to have more offspring, survive better, and and building on what you have, and the whole story basically. And there's absolutely no reason to believe that it would at some point just invented this kind of general problem-solving ability that underlies everything, because it hasn't in any other species we've seen. So why would it suddenly have happened with us? So I think that what we call intelligence is this kind of jumble of adaptations to various things throughout evolutionary history that are connected in that they are kind of built within the same organ in the body, the brain, but don't necessarily have much in common, and don't necessarily build on each other. There's no core to it. So what I think, when it comes to understanding intelligence, I still think artificial intelligence can help us understand intelligence by deconstructing it. This is where people complain about artificial intelligence and the moving goalpost problem. We all know through the history of artificial intelligence that people set up these goalposts, and when we reached them, you just moved them and said, oh, this wasn't the goal, it's something else. Like, hey, we thought in the beginning that smart people play chess, and chess is like encapsulates everything about intelligence. If you can play chess at the grandmaster level, you are truly intelligent, because you need to understand your opponent, and you need to basically you need to outsmart them, you need to plan ahead multiple times and so on. And then computer scientists work on this for 50 years, and we get Deep Blue, and Deep Blue beats Kasparov at chess, and we had won. We reached the goalpost. But then you look inside the box, and it's just a bunch of search algorithms and some heuristics and stuff. And you're like, this is clearly not intelligence. Clearly we were wrong. So basically, we moved the goalpost. What about if playing Go is like real intelligence? Because Go, you need to recognize these patterns and so on, which you don't need to do in chess in the same way. So computer scientists work on this for 20 years more, and then we conquer Go as well. And then we see that, oh, well, this was just like, Monte Carlo research with some deep neural nets. This isn't a real intelligence. So then we keep moving the goalpost. The beautiful thing about this process is that we are like chipping away at intelligence. We're basically saying that this is not intelligence, and this is not intelligence. This is not intelligence. Right. And at some point, we will have made computers do basically every single thing that we thought required intelligence. And we will still feel that we haven't really arrived where we thought we would go. And the beautiful thing about this is that then we would be free of the concept of intelligence. We would have deconstructed it, taken it apart. And there's nothing there.
There's a lot. Yeah, there's just a lot to say about that. I think earlier in the discourse, you were alluding to general conceptual confusions around what it is to be intelligent. Right. So like where exactly you draw the line for cognitive, I think largely this is an epistemological question. I think new epistemological tooling needs to be brought to bear on this question, because I think that and agency and consciousness are a couple of the ones that I think are just surrounded by these difficulties and these like thickets. And it makes it really hard to reason about, what's going on. But I think another thing that bears on this is the fact that human introspection is shallow. So this is a point we're always returning to. It's that, a lot of what is going on is either impossible to witness or very difficult to witness. It's the sort of thing you got to meditate for a long time to even see happening at all. And I think that's what drove a lot of people's optimism about the early AI research program. They believed it would take half a year and like a dozen people to basically arrive at AGI. I think partially it's because when you look out at the world, you know, I recognize books, I recognize lights, all of that just kind of hits me phenomenologically at once, but I'm not aware of the like dozens or hundreds of underlying processes that are feeding me that information. So it wound up being very difficult. It wound up being very difficult to make real progress on those things. But conversely, it ended up being possible to approximate a lot of thinking with just search trees that are deep enough. Like maybe it doesn't count as thinking or reasoning in the same way that a human being is engaging in that process because it's not an agent. And I think there's a lot to be said for that perspective. But if you just stack enough of these layers up, or if it's deep enough, it's so powerful that it's still able to compete at a human level with things. But as you point out in your book, Deep Blue can't do a single other thing. It can't be repurposed and it can't learn other things. So there's obviously something missing in the case of even a really powerful narrow intelligence, which is this generality that we're looking for in AGIs. I'm not prepared to give up on the concept yet. I'll buy your book, but I'm going to read it and I'm going to disagree with parts of it, and I'm going to keep thinking about it. And I'm going to keep thinking.
It's good. It's good. I mean, if you buy my book, I get like $1. So I'm in favor of that. So like, you buy 5, I can get coffee. But it's yeah. To be honest, I can't stop thinking about general intelligence either. My task, my sort of stated position is that I think I'm a non-cognitivist, and I got this term from theological non-cognitivism. So basically, you have theism, atheism, agnosticism, etc., and then theological non-cognitivism, which means that the term God holds no meaning. So basically, you cannot say exists or doesn't exist, or is great or is blue or whatever, because the term doesn't refer to anything, and not that it refers to a non-existing thing, but it's a meaningless term, and that's what I say about AGI. Now, as a matter of fact, I spend a lot of time thinking about what is kind of generality, what is it that models can do and that they cannot do, what can minds do, what can they not do. Like, to take this very specific example, like there's a lot of bad thinking and some good thinking about the question, like, can LLMs reason? And this is kind of a very specific instantiation of one sub-question around general intelligence, right? And it's great thinking about, because it forces you to analyze the concept of reasoning. What could possibly be meant by reasoning? And there are people like Rao Kambambati that are doing excellent research on this, where they basically try to look at like what can be done and what cannot be done. If you ask them this kind of thing, when they solve the problem, what are the properties of problems that are hard to solve? And I tend to think of it as there's some kind of like, with Kahneman, there's system 1 thinking, there's system 2 thinking, and many machine learning models are very much system 1 thinkers. Many kind of search algorithms are kind of system 2 thinkers, which is not an original thought at all. Many people have said versions of this, but there are like fundamental limitations to what something like an LLM can do in terms of system 2 thinking, because it's a feed-forward process. You are not going to get it to basically do forward simulation of a symbolic system, and you're not going to make it do best first search in hypothesis space, both of which are something that is done in like classic symbolic AI. And which is how, you come up with like automatic theorem provers, world-class chess players, things like this. Then you can, of course, ask, are humans doing these things? And Are they good at it? Are they? Um,
So I'm sure you're well aware of Ray Kurzweil and his book, The Singularity is Near, and his latest one,
yeah,
The Singularity is Nearer. Um,
yeah. I haven't read the latest one. It's like all kind of. I saw it in a bookstore, but yeah.
I think it's pretty much a reiteration of the old one, but with a few footnotes in it. But so in your mind, what happens in 2029? This is being held up as the big year everything changes.
Yeah.
Do we all just yawn and go on?
No. I don't know. I have no idea. I mean, something will have changed. What will have changed? I don't know. It's like I do think that the way we humans function as a society has a way more kind of like it's a way more inertia than pure technologists like to admit or like to understand, and that in general we tend to find ways of function more or less like before, even though we have new capabilities. Is this good or bad? I don't know if that's a relevant question, but it's like how humans tend to behave as societies. I mean, some things will have been solved in a sense, like, will we have self-driving cars? Maybe. Will they be street legal everywhere? Probably not. I don't know. Will we have automated cancer diagnosis? Will we have lots of drugs developed by AI that actually work? Hopefully. I mean, that would be awesome. It is actually really, really hard to tell. I think there's like an instinct to basically say that everything will change. But in the history of the world, everything has never changed. And I find this like, this is like an extremely strong baseline, even though particular things changed a lot, like, we invented the telephone, we invented the atomic bomb, or like, the Black Death came and sort of, killed a third of Europe's population or something. A lot of things changed, but like everything didn't change. A lot of like how we lived kept being the same. And that would be my baseline prediction, is that mostly things will be like now. Now, some particular capabilities might be much stronger. And it's really hard to predict which ones, because AI progress is very hard to predict. Very few people would predict the past 4 years of progress in LLMs 4 years ago. But you thought the progress would be somewhere else, and people were really scared about DeepRL. And people saw Alpha in AlphaGo 0 or something and said that, oh my God, we're on the verge of AGI. And the same people would be like, well, obviously that was silly in retrospect. We always kind of overestimate generality of new technologies, or something.
I think that's true because you're seeing a process that heretofore had only been achieved by an agent that was a general intelligence. You see that and it feels scary. It's like, it's like if you just see a bookshelf stand up and start walking around, it's just like, that shouldn't be able to do. It blows my mind.
Oh my God, what else can the good ship do? No, it could only stand up and walk around. Also, it still has books in it, but yeah,
now my books are everywhere. One question I wanted to ask to kind of tie together the artificial intelligence and the game discussions is about the difference between, you may hate this question, but, sort of the appearance of intelligence and actual intelligence. And this came from a friend of mine who works in game design. And we were talking about this interview, and he thought of it like, because he's been thinking a lot about AI in games as well. And so I mentioned that was one of your primary focuses. And he said, well, in the context of game design, like an agent doesn't really have to be smart. It just has to kind of appear smart. But that facade is hard to maintain for like a long period of time. So he wondered, and I wonder if you have any thoughts about that.
Do you need a dynamic and knowledgeable speaker for an event? Thomas Fry, and me, Trent Fowler, are both seasoned keynote speakers able to converse on a wide array of topics to audiences of all sizes and skill levels. Go to the contact page at futuratiPodcast.com to book Thomas or myself today, and let us apply our years of experience in public speaking to make your event a smashing success.
Yeah, so I mean, this needs a bit of contextualization. So for a long time in the games industry, when you talked about AI, you talked about a specific set of technologies that had very little to do with AI as you would do it in academia. You talked basically, for a long time, what you did, AI in a game was basically controlling the non-player characters, and you would use state machines, later behavior trees to figure out what to do, and you would use pathfinding algorithms to move around, and then when you interacted with a human, you would have a behavior tree. This is still like, or like not a dialogue tree, basically, with
Right.
what you could say and what responses were and stuff like this. And this is still the most common way, I would say, to build an NPC: pathfinding plus behavior tree plus dialogue tree. And this is basically, it's very much like all about appearance. Like what they are doing in each particular state is kind of, I wouldn't say scripted. Sometimes scripted is the right word, but generally designed. Humans have designed what they're doing here, what they're doing here, and so on. There's no learning. There is not much emergence. There is not much depth to it. And if you went to Game Developers Conference only a few years ago and said that you worked in AI in academia, you would be like not taken seriously because you didn't understand game AI, and game AI is a completely different beast. This has begun to change, not because of the game AI programmers, well, some of them are open to change, but because of people in other roles in game companies, and particularly management, that are trying to push kind of machine learning and other kinds of academic AI into games. I think that games, it's a matter of expressing myself like diplomatically as well, if someone from the game industry is listening here, because I have had strong views in the past that would have gotten me sort of shouted out of the room in the game industry settings. I think games will keep largely focusing on appearances because that's what is often needed to provide a particular kind of design, and basically like the vision of the designer. Because what people who have never tried designing a game often don't get is that if you just throw everything in there, you throw all your machine learning and so on in there, you break the game, because the game is to a certain amount, or like above all, it's a designed experience where someone has had a creative focus and like basically a vision for what they want you as a player to experience. I think that we will also see the emergence of interactive experiences built on more fundamentally interesting types of AI. These will probably coexist with what games that function as we see them right now. But they will be something different. Maybe these two things will merge at some point in the future. One thing that's like the game studies professor Noah Wardrip-Fruin at UC Santa Cruz had this great book a couple of years ago where he talks about, well, maybe 10 years ago, I don't know, where he talked about the tailspin effect, the SimCity, the ELIZA effect, and the SimCity effect. So the tailspin effect was when you had like a very complex simulation system or some complex algorithmic thing, but what comes out in the end is like pretty simple, and you don't appreciate the complexity beneath it. So the tailspin was like an early story generator that there was a lot going on. There was like a whole huge AI system, and what came out were pretty inane tales that like just seemed random to most people. Then you have ELIZA. ELIZA is the classic, parody of a Rogerian psychotherapist from the 60s. Basically, and and when ELIZA came out, many people were like, "Oh my God, it's a real psychotherapist." No, it's a computer program. Oh, really? But you can use it for psychotherapy. And behind the scenes was super simple. It was really like, just like a bunch of scripting. And that's like the opposite. You think there's something really deep there, but there isn't really. And then you got like something, the Holy Grail is kind of the SimCity effect. SimCity is a game which is built on like really complex simulation. And as a player, you appreciate the really complex simulation and interact with it in depth, which is very cool. I mean, that's why it's like one of these all-time great games. So I'm not sure that was an answer to the question.
What it'll have to do for now. Thomas, are there any last minute questions you want to ask Julian?
No, I think this has just been a fascinating discussion. I know I learned a lot here.
Yeah,
as well.
Yeah, no, there's a lot to say. There's a lot. I don't think we should stop thinking about artificial general intelligence. It's like one of the primary concerns of humanity to some extent, or at least some of us weirdos. But and it's like it's a way of understanding ourselves. But I do think that focusing on it as like a single thing, which is like, how are we going to get there? When are we going to get there? As like, if there was like an endpoint that is AGI, when are we going to reach? What happens when we reach AGI? It's kind of counterproductive. It is much better and more useful, but maybe a little bit more boring to think about what kind of progress will we do on specific capabilities. If my 20-year-old self would hear me now, he would hit me, because my 20-year-old self really, really was into AGI and really this was like, one of the core things that motivated him. But alas, my 45-year-old self is boring / wiser. I don't know which one.
Well, okay, so you do want people to buy your book?
Yeah, please buy my book, Artificial General Intelligence, from MIT Press. It's out on September 24th. And, it's short, it's cheap, what's not to like?
Yeah. Well, I liked it, and I thought that it was a very interesting primer to a lot of these issues. It was very level-headed, very thorough. It had a lot of fascinating philosophical and historical context as well. So yes, please go buy it, read it, and don't stop thinking about AGI. What about your Twitter? How can people get in touch with you?
Yeah, so I'm Togelius at Twitter, Togelius, and it's like 7 people in the world with my last name, so you just put in Togelius anywhere, and you'll find me in various ways.
Excellent. All right. Well, thank you so much for discussing these things with us. Thanks for your time. Best of luck with future.
Thank you so much, Trent and Thomas. It's great. It's been an excellent discussion.
All right. Thank you.